Welcome everyone. Today we're going to discuss about the ensemble learning. So first one is, what is ensemble learning? Ensemble learning is a technique that combines prediction from multiple models to improve overall performance. So in this technique there is a lot of models are there. So based on this, combine this all models, finally we predict that value. So that is the ensemble learning. So the idea is wisdom of the crowd. Goals reduce bias, variance, or both. So that is the ensemble learning. So why use ensemble learning? The individual models may overfit and underfit. So what is overfit and what is underfit? There is the two types of data are there. One is the training data set, another one is a testing data set. Okay. So in this training data set, we are using the 80% and testing data we are using 20%. So the overfit underfit, this is the it's not suitable for training and testing. That is a real time, it is not suitable. Why it is not suitable means, if that data is in the training condition they prefer well, but in the testing condition prefer not well. So that is, you get the output is not a accuracy one. That same underfit also, the if the training set it is not prefer well, but in the testing it is prepared good, give the good accuracy. So the both are that not is the balanced one. So it is the overfit and underfit, it is not the good for the testing and training purposes. But this is the generalization. If that they do well in the training time and then do well in the testing time, so that is the generalization. Here that ensemble methods using that improve generalizations, reduce errors and enhance model stability. So we need that generalization method. So both they well in that training time and testing time. For example, if a student perform well in the terminal test, so test 1, test 2 and test 3, there is a 3 exams. So the both 3 exams they prefer, they scored above 90, 90 above. But and then final exam, there is a semester exam, they do getting that 90 and above, that is a good one. That is a generalization. But in this overfit and underfit, it is not. If the terminal test they score well, but in that semester they not score well. But in the same time underfit, there is a training time they not score well, but in the testing time they good score well. So based on this, that is we improve the generalization, reduce errors, enhance model stability. So the types of ensemble methods, bagging, that is like it is a bootstrap aggregating. The next one is boosting, stacking, voting classifiers. The first we go for the bagging. So the bagging is that train multiple models. Already we discussed in the previous slide that there is the different types of models are there. So these models are predicted the same output, but that every which model is suitable. So that is a training multiple models on random subset of training data with replacement. Okay. The final prediction by averaging, that mean averaging means that is a regression, or majority voting is a classifications. Okay. So how that averaging predicting, that is the using the multiple models, that each model gives some outputs. So we add these values and get that average value. Getting that average value, that is the final output. So that is the regression method. And then majority voting method is a classification. So if suppose there is a 5 output, that model giving the 5, using the 5 model, they giving that 5 different output. The first two models giving that value is output value is 1, and third one giving the 0, fourth one giving the 1, and fifth one giving 0. So here there is a maximum voting. So the 1, 2 and 4 giving the same value, and the 3 and 5 they're giving the different value. So here, based on that majority, we choose that classification method. So that averaging using the regression, and then classification using that which one is the majority. Say example, random forest. Boosting. So what is boosting? Train model sequentially. So that is a one by one, that is a train the model. Okay. Each model focuses on the error made by the previous one. Suppose if they give error in that first one, again you have to that rectify that errors and produce the correct output. Final prediction, weighted combination of all models. Okay. Example, ADA boost, gradient boosting, XG boosting. Next one is tagging. That is a stacked generalization method. Combine different types of models. Example, SVM, decision tree, and KNN. Use a meta model to learn from their predictions. There is a two level, burst learners and meta learners. Voting classifiers, hard voting and soft voting. Already we discussed that is a regression and classification method. So that is a hard voting is a majority vote. For example, that election, real-time example, that is a election. Uh, in that Tamil Nadu, there is a totally 234 assembly legislative based on who chooses the majority. So there is a they have to ruling party. The soft voting is a average prediction probability. Here not is choosable for the majority voting. So here that is based on this output, that is the average that values. So that is the next combine different logistic regression, SVM, random forest. Those are the using in this voting classification. In real world applications, we using applied in this method: finance, healthcare, cybersecurity, and e-commerce. So finance credit scoring using random forest, healthcare decision prediction using gradient boosting, and cybersecurity intrusion detection using ensemble classifiers. E-commerce product recommendation using stacked models. So that is the real world application we apply. Thank you.